So next up we've got Marco Mancini.
Hello, everyone.
Marco is the tech lead for Marco is a tech lead for detection engineering and at the company Thought Machine, which is a cloud-native core banking company, where he focuses on incident response, security monitoring, and data-driven solutions to several security problems. Today, Marco is going to explain different logging patterns that you can find in public clouds like AWS, GCP, Azure, and lessons learned from building and rebuilding security logging at different scales. The title of his talk is Security Logging in the Cloud, Trade-offs to Consider and Patterns to Maximize the Effectiveness of Security Data Pipelines. Everyone, please welcome Marco.
I'm so grateful you said the title, because I think I was going to repeat it a lot of times. So, security logging in the cloud, for short. This is a big introduction. Don't worry, I'm not going to read everything. But let's just start with why this talk, I think, will be interesting for people in this room. So a lot of the times, and especially after you come from DEF CON, so you will go back to your offices, your businesses, and you will be, okay, guys, we need to enable all the logs. There's these attacks, there is hackers that can do things that if that we have no logs, we will not even be able to know if we have been hacked. And especially after you start doing it, you realize that the cloud contains a lot of logs, a lot of different sources, and a lot of different things you can introspect. And the cloud really, if you go to the documentation for all the cloud providers, they will even have warnings. Not the warning of, are you sure you want to do this? It's, you should do it. It will cost you money. We don't know how much, but it will cost you in big letters. So be aware, there will be cost. That's in their documentation. And also in general, doing data logging pipelines, it's not an easy problem. Like when we were doing things on-prem, a lot of companies would just leave the logs for their Linux machines, for example, their Windows machines in the machine. So when there was an incident, the forensic investigator will still grab the physical machine and investigate it. In the cloud, that's a bit more difficult, but on the other hand, the cloud providers have given us the tools to actually move to a 21st century style data logging and analytics platforms. So let's go for first, who am I? I was introduced very well, but I am like, if I didn't say I'm the kind of person that have told every company I have worked in we should log everything, you may not get that idea from this talk because I say some blasphemy between like data people, which is maybe we don't need this data. But I'm the kind of person who will tell, we need to log everything because otherwise we won't be able to find the threats. And especially we will need it if we get hacked to do forensic investigations in the cloud. So, some details about Thought Machine. Apart from doing core banking and payments, I know exciting stuff. We are cloud native environment, multi-cloud and Kubernetes native, which means that we cannot only rely on one cloud and their way of doing things. And between implementing logging on every single cloud, especially AWS, then GCP, and now I'm starting with Azure, I'm realizing that the tiny nuances between the clouds make a huge difference in terms of cost and performance. And then Kubernetes, very fun, and the logging, it's even more complicated. And the problem is, funny enough, Kubernetes, it's like a cloud inside the cloud. Like you will often have like, the cloud at the end of the day, it's just an API for people to do stuff, for people to manage the machines, for people to manage everything. Kubernetes is the same thing. So you have an API, and then the Kubernetes will manage the compute, will manage the pods and everything. So Kubernetes needs to be introspected as much as the cloud. And then you go every single layer of abstraction, and every single layer has their own world of logs. And you pay for all of them. So here I want to start with what the problem that we have, which is engineering and security engineering is the art of constraints. Like if we had infinite time and infinite resources, security wouldn't be a problem. We'll patch everything, we'll have all the logs, and we will be able to have perfect security. But in the real world, that may not be as easy. So because we are not protected, we cannot protect everything, we will need logs to understand what's happening and to investigate if something goes wrong. It's a tiny log, like the presentation has a lot of graphs and diagrams, so at least you get a nice image before we go into the boring part. So I want also to preface that a log can be thought as a representation of an event or an action performed in a system. This seems very broad because I think of logs on not only like, for example, a EC2 instance being spawned, but also things like a new employee has been added to payroll. All of this data, you need to correlate it. You need to understand everything as a whole, and it needs to be able to be matched with each other. Like if an employee has not been added to payroll, but this employee is adding compute, that's strange. And may that compute be a crypto miner, and that employee may be an account created by an admin. Like that's the kind of thing that we need to worry about. So, data, DevSecOps. When you are building a data application, you need to think about the users. In this case, the users will be analysts and people doing forensic investigations. The problem is, the constraints for security logging are very stringent. Like, very few systems you need real-time, immediate search, very long retention, like years of retention, highly contextualized data, precise data, so you cannot do sampling. And it needs to be extremely reliable and tamper-proof, which means that you cannot take out of the shortcuts that other systems can. And also, it needs to be easy to use and visualize and aggregate things, which is sometimes data people we forget that the data and the parameters that we build are for humans to use. So, all of this, actually the cloud providers have built things to help you achieve these constraints. The only thing is price. If you put the slider on price to the maximum, don't worry, you will get that. But the bill may be, like your finance team may not be happy with this. And then, on the other hand, hacking. Like where the hacking lives, why hacking is not gonna go away in modern society. It's because the constraints that we have build gaps. In these gaps, hacking and red teaming and exploit research lives. Like if you cannot solve every problem because of the price of hosting, the engineering difficulty, or even the price of licenses. If there may be a vendor that solves all your security problems, but probably their license is going to be outrageous. So, logs are expensive, and they can, depending on the log, it's more or less expensive, but in the cloud are vital. So this talk is how we can get to as much security as we can in terms of logging without price being a constraint. Or it will always be a constraint, but it shouldn't be something that I have seen some places, and I have seen people tell me, security people will go to a company and will say, we need to log this thing. Everyone, I think, well, not everyone, but a lot of people can be traumatized by enable VPC flow logs for the first time. Like, yeah, exactly. Security people will be like, we need this, definitely, enable it, go get a nice weekend, come back, and then the finance team will be at their desk going, what do we spend 50K more? And you were like, this is for security, so we need to find a way. They will probably traumatize and try to stop you every time you do something again. So, let's talk about some case studies on like particular examples of how this will work. So, logs should scale with the amount of instances, IAM, and then general resources that you have, okay? So, this should be like a nice linear graph, but if you see here, it doesn't tend to be like this. The more you grow, the more problems that can appear in your logging. This, for example, would be a CloudTrail logging, which is, I think, the one that you should really, really enable. Like, well, like they call it management API. Because otherwise you will not know what people are doing on the environment. The thing is, this function of scaling, it's managed by different parameters. And in this case, you have human-produced logs, which I'm not that worried about them because humans don't tend to wake up one day and do 10 million actions in 1 second. You find some humans like that. That would be a problem. And then you have application interaction. This, I'm going to talk later about that, but this can become very problematic very quickly. And then baseline operation. This is something that when we think about the cloud, we think about that. But you will see that can become quite problematic in certain circumstances. So I already explained a bit of what they are, but the application interaction, it's the like you can find friction between apps. Like apps that require authentication from other apps, apps that trigger other apps, and in general, things that manage other things and the things that review other things. In the errors between these interactions, you can have explosion of logs. And especially if you get apps that don't work well with each other, you may have, like you will see later, like log explosions. Then you have baseline operations. These are things that can be too noisy just by configuration. You can have a misconfiguration in which you get an application that checks the health, and then someone goes, I want the health to be known at real time. So they have a refresh time of 1 second. Maybe knowing the CPU usage per second, no, not that useful, but this can very easily, because of configuration and assumptions of where the costs go, become kind of unmanageable. And the thing, at the end of the day, we want to know everything all the time. So how we can make this happen? So this is also an example. It's not like the problem with the cloud, and in general, when you go to documentation about logging, there is a very easy question, which is how much something will cost. The cloud provider doesn't say, and it doesn't give you any tools to actually understand how much would you pay for these logs. I mean, you know how much would you pay for gigabyte, but you don't know how many logs you will have. Because the problem is, when you start looking into this, you may find that at different levels of scale, your logs start being polluted with things that you don't want. So you always want to be in the green, in the high signal logs. These are, for example, new stuff being created, containers that are suspicious, new administrator accounts being created. It's the kind of logs that if something bad happens, you will look at them. The blue ones are still useful, but are things like how to find reconnaissance. Like that may be like 1 million logs, maybe just related to one scanner. In these cases, these logs don't provide that much value, but they are still relevant, and you want to keep them, but you want to find ways of actually store them, giving up one of the other constraints, like for example, immediate search or high retention. Those logs are the only ones I would say you should be safe sampling them. And CloudTrail in this particular case actually does this distinction, and you can have something they call event filtering, in which in general in CloudTrail you can divide between like write operations and then read operations, and only collect read operations. Only write operations will be the one that you want. And in that case, AWS has identified that it's clearly you need to have the distinction between high signal and low signal. And also I want to say something that security teams don't tend to look at, which is errors. Like, these can become out of hand very quickly. And I have seen applications that are so efficient that if they don't have the proper IAM, they will tell you. But they will tell you at a rate of 1 million logs per minute. Like, great, go, fantastic. But that may be a problem. The thing is, these errors, often only the security team are looking at them, because these would be errors of authorization. And if people are not managing their applications properly, these errors will start polluting your environment. And it only takes like a couple of applications to do this and start exploding on your logs. And the thing is, I would say, fix the errors. Like, tell the teams, like, security, we tend to be siloed, thinking that our value is security, but when we have a really good data stack and observability stack, we are able to like help other parts of engineering to be better and to make systems more efficient. And if they eliminate the errors, we pay less logs, and now when an attacker is trying to hack into our system and they don't set things properly, they will trigger errors. And now that error is a high signal log. So there is a lot of value in helping engineering solve errors. Like, for example, unauthorized. I wouldn't say the tool, but I'm sure people will find them. So here, I already talked about it. This. It's example of errors and misconfigurations, like setting refresh rates that are way too low, services that logs are way too verbose. Like there may be, and this is, the cloud doesn't do this as badly, but there will be applications that they will send the log and they will just send a stack trace on the log. And if there is a constant error that gives you the whole stack trace, that can become completely unmanageable very quickly. And by unmanageable, the cloud will manage it. You will just get the bill later. the good things about modern cloud operations. Then this thing, it's about like underlying errors. I have encountered like some log sources that 90% or more of the logs were just an error from very efficient applications. This makes my life a lot easier because less errors, more signal, great, and less cost. So these are also some examples that I have, how it's called, shoot my foot off without realizing. So CloudTrail, errors in authentication, third-party services, infrastructure as code doing constant changes, that's, you really cannot filter this out. You really need to be looking at them, but if the infrastructure as code is misconfigured, that may pollute the system a lot, because these are the kind of logs that you really need to care and put them in cache or really expensive storage. Then cage logs, this observability tooling, fantastic, but you need to be careful of how are those refresh rates, how much introspection is, and how they attack the API. Because a lot of the things would just go constantly against the API as fast as they can. Then on VM, EC2, and an instance of some kind, syscalls. This, I think I could write a whole book. Like you really need, if you really want to understand what's happening on your environment, syscalls will tell you everything that has happened real time. There is very few ways of escaping them, because that's, in Linux, that's how the kernel works. Problem is, that can explode extremely easily. Like just an application doing syscalls, they can, if they are extremely efficient, this can even bring down performance on the, like, on the service. Now with eBPF, things are better, but back in the day with ODD, that could become a performance problem very quickly. And a performance problem on a machine can become an expensive bill on storage, especially if you need to retain things for years.
Excuse me. Did you say ODD?
Yeah?
Did you say ODD? Or,
Yeah.
oh.
Now eBPF, fantastic. ODD, I also love it. It's great. I'm not sure like finance people love it, but we can always win. So VPC flow logs. This, I really love this example because this is one of those extremely useful logs if you just get the log that you want. If there is an incident, VPC flow logs will often tell you what got out of the cluster, how the attacker moved inside. But the problem is this, even in an incident, this would be a very, very tiny part of these logs. And especially, VPC flow logs, the cloud will just recommend it, you enable it for debugging, which means useless for forensics, sample them, which means that if you just get a sample of 10%, you have a 90% of not seeing the log that you want, and aggregation. Which aggregation is one of those things that for security I think we will have to consider, but the problem is it adds delay, which is one of the constraints that we have with security logging. Because if we have a 15 minutes delay on the logs arriving, it's great for costs. Because for example, instead of getting every single request, you just aggregate 1 million logs into one nice log. Problem is, if an attacker is very quickly, that aggregation would be, oh, that's a cool attack. That happened 15 minutes ago. And the attacker is doing other things. So, going to the second case study. So the first one was about logs and about signal. The second one is about the pipelines. Because the pipelines actually matter. like the order you do things and where do you put the data, it's actually quite important to make sure that your system is performant at many levels. So, this is a particular example. This, I went for EKS audit logs, one of the things that keeps me up at night, I guess. And these logs can be extremely costly because it's, as I said, it's an API, like it's a cloud inside the cloud. And if you are managing EKS logs, let's say, like here I ask around, and people who are running like 1,000+ nodes with EKS, a lot of them are getting 1 terabyte per day of logs. Managing 1 terabyte should not be that difficult in nowadays, but if you really want these logs to be useful for security, thus meeting the constraint that we have, then we are encountering some serious price. Here, I'm not gonna go with like every single piece. I have another diagram that goes into how things are. But the thing is, I would say here there are like one of the 3 most common ways I'm seeing security logging in terms of pipelines, which is guard duty only, for example. If someone goes, data is too difficult, but I just want to know if I have hacked or not. So enable guard duty starts checking the logs and tells you when something is wrong. This, fantastic. As an starting, great. And in terms of cost, this will be the most efficient one. But then you lose a lot of the good, like a lot of the constraints that we have, which is, it will be very hard to know like what are other systems doing that are similar to that guard duty alert, because that guard duty alert will not tell you the context. It will tell you a bit of context, but you will have a hard time understanding really how your application works. But in general, it's not a bad start. Then if you just are like, guard duty, it's too difficult, it's too expensive, but it's not too difficult. Let me roll it myself. This is a lot more expensive. This is using kinesis, which means that you are not even doing high retention, and you still have to do all the alerting. This is not bad, because then you can do some interesting things in this space, but giving away guard duty for custom alerting, you really need to know what you are doing, because most probably you will get less value for more money. Unless you are very good, then if you are very good, it's fine. But so one of the things that I think are what I would believe, now AWS is changing a bit, but they used to recommend more of storing all the data in S3, querying with Athena, so you got all the nice ways of understanding data, doing data analytics, and then getting guard duty for alerting. This would be more than 40K a month. And you may be asking, what are these logs? Why 1 terabyte? What is this data? And the thing is, data teams, you will ask them, please, I need these logs. And they will be like, it's 40K, but I guess for security, we'll have to do it. But they are not the ones knowing if those logs have value. And from that terabyte, we have the issue that most of it is read operations. Most of it will, at best, show you reconnaissance, but at worst, it just show you the tools that you know they are running. And that very interesting logs are not even captured. Like for example, the normal KH logs will not tell you exec operations inside a pod. They will tell you that a pod has been executed, but not the commands that have been run on it. And then you will have 1,000,000 times a observability tool that has checked if the system is alive. And there's no way natively of filtering these logs. So, this nice diagram, love diagrams. In general, here the issue in cost is CloudWatch. Like CloudWatch, it's 50p per gigabyte, which means that even before you touch S3 storage, you are going to pay a very high tax on the logs. Even if you use Kinesis or S3, that CloudWatch tax will happen. Other services from AWS don't require you to go through CloudWatch, or require to go to CloudWatch in ways that you can filter them before you pay. Google, on the other hand, for example, they have instead of CloudWatch something called Cloud Logging, and they do something called exclusion filters, which before you pay, to put into a sink, you can make a search that will filter the logs. So if you know your applications and you know that that application cannot be malicious, or even if it's malicious, you will not be able to know by looking at a particular operation if they have gone malicious or not. You can filter it and then only capture what you really need. And when you have what you really need, you are able to get that data into much faster cache and then do a lot more interesting stuff. For this particular case, like I've thought a lot about it, and this is the kind of, like if you're using non-managed case nodes for EKS audit or GKE or EKS, non-managed nodes, very simple. There is an audit policy. You cannot click here on the presentation, obviously, but when I share the presentation, you will be able to, in which you can just filter the policy, change the policy, and tell exactly what you want to collect. Like Cage, it's actually very good in this. You can filter things, and then you can get different levels of logging. Like go deeper on getting the information of what's happening. In this case, be aware that this may contain secrets. If you like audit policy, if you do them wrong, they can be quite dangerous. And in general, the managed service will be very good in filtering all this data that you don't really want in your SIEM. Then you get the managed case clusters, which is the problem that we are encountering here. Here you cannot change this audit policy. You cannot touch the control plane, and you have to live with what the cloud provider gives you. Otherwise, it wouldn't be managed. The thing is, one thing I'm not sure I would recommend, but it's something that we have been doing. It's using a mission controller. A mission controllers in Kubernetes, they subscribe to what's happening on the cluster. So they subscribe to the control plane and they get every operation that makes a change on the cluster. And that's exactly what we want. And with an mission controller, you can actually just analyze and do alerting in the cluster, or ship just a tiny subset of things, going from a terabyte of logs to a gigabyte of logs, of actually things that change the cluster. If you're an attacker, I'm sure you are happy doing recon, but what you really want is doing changes. Then one interesting thing in terms of pipelines, you need to think about retention and storage. In Athena, for example, Athena goes against S3, but you don't have to be a standard storage, high speed. You can move them to Glacier. You can do lifecycle policies that after a certain amount of time, you assume that the logs won't be for real-time incident response, but it will be for forensic investigations, which would have different requirements in terms of the speed. And that can save you a lot of money. But the final case study, let's say, this has been the journey so far. The start, I was like, you came to DEF CON, realize you need to have full visibility, so you go back and go, we need all the logs. But then you went and did all the logs, and your finance department was like, I don't think we can afford all the logs. What do we do? And when they ask you to start turning off logs, you're like, wait, let's just get the high signal logs. And that's when you start getting a lot more value from the logs, and you really start to understand better how your organization works. And then you move to more efficient logging pipelines. Like same logs, same high value, but more efficient ways of getting your data. And this is giving up things that you may want. Like for example, you can aggregate, you can filter, you can transform your logs. Like aggregation of security logs is very useful. Like you don't need to know, for example, that like a million logs may be just one person accessing a server. Obviously, like when we go from pickups to like network logs, there we have gone and we have done an aggregation. We are able to introspect less, but we're not losing that much for compressing and like removing a lot of the things that we don't need from that data. And then at the end, if things go really grim, people will be like, what if we have no logs? What should we do? What is the forbidden thing about like going no logs? I'm sure the answer will not surprise you, but let's analyze this for real. So If you cannot have logs, like cloud logs, then you have forensics, API-based reports and assets and metadata, and agent-based detections. So on this, forensics, it tended to be the old way of doing things. The old way of doing things had a problem now moving to the cloud, which is the cloud things are virtual, things are ephemeral. So as a forensic investigator, you may go to an incident and realize that the data that you need is no longer there because the machines are no longer there. But forensic data scale with incidents. So if you have very little incidents, then you will not be paying that much. But forensic data can become, it will become expensive, but it will become expensive because the analysis and the data acquisition is quite complicated. Then you go on API-based reports and asset and metadata. This is kind of a weird thing. Probably there is a buzzword for this. But for example, these would be tools like OS Query, or these would be tools like Cloud Query. Like, they would be things that scan your cloud, and you will be able to detect drifts on it. So for example, you may scan all your users, and then you scan again all your users, and you then see that there's a new admin. And the new admin has way too many permissions and is not related to any of your normal changes. That can be very useful, and in terms of costs, it will be very cheap because you are storing a snapshot here, and then you just need to keep few of those snapshots, and doing the correlation is not that compute intensive. The problem is, then again, frequency. If you do a frequency of 1 day between a snapshot A and a snapshot B, an attacker has a full day to use those admin credentials, and it may be too late to do anything. I think this approach is quite good as a baseline and as a first approach to the problem. Like, if you don't have any logs, going to 100 visibility and everything being efficient will take a while. These tools, the tools that I think a lot of the open source community are doing, are very good to be able to get and knowing what is my environment doing. What has my environment done between day A and day B? Then you have agent-based detections. I think a lot of the vendors really go into this problem because you then move to compute, and then they have, the thing about this is, if you know the attacker and you know the attacker very good, you are able to make the intelligence and then put it in the agent, which means that the agent will be very adept at finding the problem, fixing the problem, and just telling you that the thing has been fixed. Problem is, this may have worked very well on on-prem or on endpoints and for fighting like commodity malware. The issue is, cloud problems don't touch compute that often. And not only they don't touch compute that often, it's the cloud native attackers, they just go to the console and do operation that would be normal for an engineer to do. The problem is, instead of deploying your new application, they are just deploying a new crypto mine. So, agent-based detections can be extremely useful, but the problem is they are now, in the cloud by design, they will struggle to replace logs. And, in a bit of an anticlimactic way, because I'm running out of time, I predicted that, that's the end of the talk. I have some conclusions, and I have a meme. So I lied that it was only going to be diagrams and graphs, but this lives rent-free in my mind, I have to say. Thank you. I have, I think, like 2 minutes for questions. If anyone has a question.
Yeah. Are there any open source alternatives that to using cloud logging that can handle the kind of scale that you're talking about that you like?
That is an excellent question. The issue is every open source tool will actually already have to pay the CloudWatch tax. So you are already paying the tax to the cloud provider anyway. And then you, I really like, I said I'm not going to do any endorsements, but I really do like some open source alternative to look at the logs and process the logs in the cloud, then move them to CMs and then analyze them. Because at the end of the day, the correlation of the data is where most of the value is. Like, the thing that security teams in companies can do that no vendor can do, it's the context. You know your company, and spend time understanding your company. That's the value that we bring. And in the cloud, I think we can move to the utopia of getting to know what's good, what should happen, and everything outside of it be the thing that we investigate as malicious, instead of just being like, we know this is malicious because we got a vendor telling us, so we are gonna only find evil. We should find not good, I guess. Any?
Do you have like a policy breakdown for like what type of policies you recommend to write or customize based off the log type? Like let's say it's a Kubernetes logs, or let's say it's like a CloudWatch log. These are the policies that you like recommend to apply to those, so that you're actually getting useful data out of the log.
Yeah. So the question is, if we have policies because I'm doing it for the future, if we have policies related to logs and related to the value of those logs. Well, I haven't published them, but we do have policies, and we try to enforce them at the organizational level on every single cloud to be like, okay, this is how you filter, this is the value, and we try to do documentation, and we also do things like health checks. Like you need to do health checks. The cloud provider will not help you in this. You need to know that the logs that you want are coming. And one of the interesting things is when you start doing detection engineering, you realize that certain data sources always require certain things. Like if you go from your rules to your data, you can build policies on the logs supporting the rules that I care. The rules that will call me at 3 a.m. These are 100% important, and they need to be stored in the best CM that we have, or the best layer of data that we have. But yeah, you need getting this down is very important. Also retention. Thank you.
All right, folks, thank you for coming.